Okay, I think let's start. Now we move into session 2. We're going to have Dr. Wuletawu Abera. He's a scientist at the Alliance of Biodiversity International and SEAT. By profession, he's a landscape hydrologist, and he's been quite instrumental in the fertilizer recommendation work and other geospatial work. So, Dr. Wuletawu, I'll hand over to you as you give us an update on some of the data analytic work that you've been involved in. You're muted.
Now, can you hear me?
Yes.
Okay, thank you very much, Po. Hello, everyone. So today I will update you on some of our activity on data mining and data analysis in fertilizer and also geospatial activities. Okay, next. Just a second. Okay, so to support the agricultural productivity using big data, it means increasing yield productivity. As you know, that yield is a function of environment management and genotype. So environment, when we say environment, it's about the climate, the weather elements like temperature, rainfall, soil addition, soil moisture, and also it's about topography. Topography is really one of the determinant factor for yield. As you remember, the team from Chris has been doing some recommendation or suggestion based on topographic position index and slope aspect is also really a key ingredient for determining yield. Soil, you know, the etiologies was really important to suggest, to recommend some nutrients based on existing soil fertility status. Agroecology zone is also one of the key environmental variables. For example, the case of OFRA, they have been developing a response curve for each agroecological zones in Ethiopia and also in other African countries. In terms of management, is basically here our focus was fertilizer application, and also it can be extended to integrated soil fertility management, generally soil management, CSA practices, and all other investments by household or by farmer is really a key management that determine the yield and the variety we select in a particular location really affected the performance of the plot. Even though there are a lot of efforts considering one or two environmental variables, for example, topography, agroecology like OFRA, and some other determinant factors, in our approach here is to use a big data approach where we consider not only one or two factors, but to consider all environmental factors as input, and then estimate yields. And in that process, our approach is the environmental factor and the are static, but the management factor we can provide some recommendations, some management. We have option for the management. So, for example, here the question will be what will be how much fertilizer I should apply in a given plot, in my plot, or what kind of soil management practice I should practice in a given plot. And for that means it's all about partial dependency, because environment affect the process, but we want to pick the management practice based on all variables. For example, here is a relation between yield and fertilizer application rate, considering my soil, considering my topography in my plot, the climate condition in my plot, all this. So considering all this static, because that cannot be changed easily, then what is the relationship between the yield and fertilizer rate? So that's where we want to produce a response curve for a different level of fertilizer application. So that can be also extended to another variable, for example, soil management, the climate smart agricultural practices. So these are similar analysis that we want to support in this initiative. So our effort was initially we pull many data from different coalition of the willing members, also different institutions. So in this case, we have more country in different agroecology zone and actually the fertilizer rate. Then we want to couple this with different historical remote sensing geospatial layer, which includes the soil, the topography position, and the climate information, which is rainfall, temperature, soil moisture, solar radiation. And then we put this in some innovative approach in machine learning idea. That means we build the model based on this data, we validate and we test the performance of this idea, and then we can able to recommend fertilizer for that specific location at any location in the country actually. So that is the idea. Now recently we have new data sets. The red one, this one we get from current institutions. Now there are more than 250, so that's really a good update in this stage. So another one is that if we can use not only the historical remote sensing or climate information, but nowcast or forecast information for the next season, then we can be able to provide the planting or early warning date. So for example, if we have information, we can replace the historical remote sensing data with the current or the forecast, then it helps us to give advisory on when to plant and how much fertilizer to apply in the next season, not just evidence the relation between the fertilizer and the yield, but also a kind of advisory service. Then we recently we also get more data from SFM project by GIZ. I would like to thank you, Dr. Taklu. He invests a lot of time and energy to collect the XY coordinate of their projects. They have been working on SFM technology, and now we have more than let's say more than 600 locations with different SFM technology practicing in the country. So that also helps us to to recommend what kind of soil fertility management can be practiced to optimize yield, and that's really important. And as you see the presentation by Ashanaf yesterday, we are also pulling many data, many soil information, and that can also be integrated into this modeling practice, and that will be really instrumental to improve our prediction in terms of the soil management, fertilizer recommendation, and others. And we are also expecting the HOSs to be both the raw data and the maps to support this initiative. So once we have all these setups, and we will be able to develop the advisory system for fertilizer, for soil fertility management, planting data, and some of other components into the extension system. So if you remember yesterday, Sakar was saying that we can, or it could be very difficult to provide advisory in each plot at this stage, but that is option. And as a recommendation, we can have site or a plot specific fertilizer recommendation in this case, also for another advisories. So we able to produce response curve for each location in the country. In this case, it's for wheat, and that can be extended for different crops given the number of samples data we have is enough. So this is just for site specific, but we can also have agronomic response unit, which is basically we divide the country into environmentally homogeneous unit, where any kind of intervention we do, we may have similar responses, almost homogeneous responses. So we are also advancing in that regard, and when we validate and test this response unit, it will be available for researchers to test and try it as a better way of doing intervention investment planning for agriculture in the country. So this agronomic response unit recommendation at this scale is also another option. So once we have all these setups and revised and discussed with researchers, then it will be tested in selected Kabale or Weredas or sites, whatever location we have options, and then we see what's the performance and what is in comparison to the other options we have so far. And once we have this one, we will deploy in selected sites, and then also we will disseminate the information of the fertilizer, the CSA practice, the SFM, and also the climate information to the farmer is with collaboration with IR, Digital Green, and other private sector that are working in disseminating agricultural information to the farmer. So once we do that, then that helps us also to get some feedback from the farmer and extension workers, and then we pull that data to get feedback and revise our advisory system in terms of analysis and revising the tools. So then it will be a loop, we improve the system, we disseminate and get some feedback, and then again we improve the system and then refine the recommendation or the advisory system. So then once we do this, we will implement in few selected sites, and once we reach at a minimum level of acceptance, then we will push to deploy into the extension system in the country. So there are also some few techniques that are helpful to improve the advisory system in agriculture in the country. So the Geospatial Committee of Practice, some of the members will have been engaged to develop some output in these few areas. For example, land cover, land use maps, agricultural land suitability maps, yield estimation and crop monitoring tool using remote sensing, small scale irrigation, soil type map. These are some of the key important products that the Geospatial Committee of Practice and the COW members try to produce and support the agricultural advisory system in the country. For example, in this slide, as you know that the land cover map is not clear at the moment. Some of them are really old and different maps are posed by different researchers. So that's really a problem because of many factors. So the plan here is to use advanced tools to identify how much hectare of land we covered by which crops, and then that helps us to estimate the national crop yield. And the other team the COW members are working on agricultural land suitability. They have to consider a lot of environmental variables, soil variables, to generate which parcel of land is really suitable for which crops, and also at a larger extent for which land use. And this, we think that this a good accurate map of this data would be helpful to improve the prediction of yield at a national scale. Another one is once we have a clear idea which crop or which plot of land is covered by what, then it's important to follow the phenology of the crop and see the performance in terms of estimating yield at the end of the season. So they are using different remote sensing data, first to estimate the crop type, second to also estimate the yield we are expecting at the end of the season. And they are trying to calibrate based on different course label data, pointer data, also granular data and then come up with different solutions to calibrate the approach. And this is also one of innovative idea to guide the transformation in agriculture. And the other one is irrigation. I mean, the focus in that presentation is about rain-fed agriculture, but I think as we have more small-scale irrigation areas in the country, it's really important to have exactly what inputs, what technologies, and what are the areas of this small-scale irrigation in the country. And so the team of this are working on using high-resolution remote sensing data with citizen GIS, because the extension agents, they have some smartphone and they can provide a lot of information on the ground. And if we couple the citizen GIS or citizen science with remote sensing data, then it is possible to produce accurate information on small-scale irrigation. So it's not only about the area and the performance, but also about the market, what kind of value chain they produce for a given location, considering the situation, the market, and the value chain performance. And this is also really innovative idea that can support the cultural transformation in the country. So once we have all these components running, and once we have a minimum prototype for each components, we should sit together with a researcher to discuss and to get wider acceptance in terms of adoption. And also we should have a capacity building with the extension service, extension agents of farmer. And also yesterday there was a discussion about academia, how we can integrate this into the education system. So maybe we can have also workshops in different level to have a clear idea of what we want to have in the system, in the extension system in the country, and also to take it further in the future. So capacity building is really a key component of this system. So I think this is overall some of the updates in terms of data analytics and geospatial components, and maybe some of the members are of the community of practice of the geospatial science are here. If they want to add a few things, they can. This is all from my end. Thank you very much.
Thank you, Wuletawu. Very interesting work you're doing. Right, so we open the floor for comments, questions, observations. I picked up here, Dr. Losegard is making, a call to the community on the importance of us as members participating in, if you've got a specialty or a niche area that you are in, let's build interdisciplinary teams. Do you want to speak to that, Dr. Losegard?
I think this will be also a discussion we will do in the afternoon. So I just wanted, if people are looking at this and they think this is an area we can improve or change or update, then to bring it to their attention. Otherwise, in the afternoon we may go into that discussion.
But you also had another question. Maybe you can explain it a little bit better. Around integrating predictive, or is it integrating? But your question is around predictive versus process-based modeling for fertilizer recommendations. What is the question exactly there, Dr. Losegard?
So it's not a question to the presenter. It is what do you call it? Discussion for the group to if anyone has a comment, because there are two. We can have a process-based crop model-based, advisory for specific locations, and also if we have a big data, then we can have a predictive model-based approach. So is there a way to link those, or are they at different scales, or is there any complementarity, or are they different? So it's not a specific question, it's just for people to see, and if there are comments.
Yeah, for sure. You're welcome to raise your hand if you want to give a comment verbally. That's also fine and acceptable. So if you just indicate, we can let you unmute yourself and speak. Tegefi is also making comments around citizen science and how it's got a great role in improving our predictive as well as process-based modeling, right? Jamal, you're saying it's better to discuss how we can enhance the number of observations to fully use machine learning or artificial intelligence approach data. Do you want to speak to that, Jamal?
Yeah, I think Jamal is a little bit worried about the number of some observations we have so far. I think, yeah, I think that is because the backbone of this initiative is having large number of data sets at different locations, having different representative data from different environments. As you can see, the presentation from Ashanafi yesterday, there was a lot of data coming in, and there was a willingness to share some of these things. So we have to be a bit practical in terms of accessing and having this data, and to improve the full capacity of the machine learning and artificial intelligence approach. Yeah, so I agree with Gemma.
Teklu, you're saying you see the comment from Teklu on how we already have large data sets. Once those are exploited, the result would really improve. Indeed.
Yes, so as we go, we have to explore, we have to see the gaps. If we have any environment who is not representative at all, then we have to think how we can cover that environment. And this year we have some discussion to pull data from few projects, so that would be also very important, because this data is also from different environments. So I think that's also a great initiative.
Maybe I come in Chipo.
Sure.
Yeah, as I mentioned here, we have already collected a large data set, which we have not yet organized and utilized. But on top of that, we know there are a lot of soil and agronomy data around, which we have not yet captured, brought into the data pool. So what we are thinking is, once we utilize those data and we get some improved results, we'll organize a technical meeting and invite people who have already contributed data, and also who are having data in their custody but not have shared. And we demonstrate how having a large data set can result in really good results, and encourage them to bring their data to the pool so that they are not left out. And I hope that way we can still get more data. But before we do so, we need to exploit the data in our hand. It's really huge. It needs to be reorganized, put into a systematic template, as we said yesterday, then converted into the database, and then use the modeling using those data, see the results, and also see where we have gaps. And one of the ways of filling the gap is calling this kind of workshop, but we can also look for other alternatives where we bridge those gaps. So I think the progress is what Wuletawu now presented is maybe halfway, but I'm sure in few months we will get a better result once the freshly collected data were factored in. Thank you.
Yeah, so as Rusangad also commented there, and Teklo mentioned, we are having, a preliminary analysis, preliminary results. They could have some uncertainty in comparison to the full data, the data that are existing in different research. If we pull them, maybe we can have more refined, more accurate performance. But right now we have some minimal enough number of data to to have a good result. So we are doing that. Maybe I didn't want to enter into the details in this presentation because it is not really a technical session to discuss a detail of each component. But as Teklo mentioned, we will have technical session to discuss each component of the performance what we have right now and how we can improve it, and then how the new data can help to improve the first round analysis.
Thank you for that. Tegaye Gema has a comment that data representativeness needs to represent all factors which significantly affect production and productivities, e.g. AEZ, soil type, soil fertility management practice, crop and domain.
Yes, yeah, I think when we say representative, it should be, capture all the environmental variables, the environmental domain, not the spatial only.
Yeah. Kindi, you're welcome. You can unmute yourself and ask your question.
Right, thank you very much. Thank you, Wuletawu, and the rest of the presenters. It's very exciting, very good presentation so far. I think we've been so far from the time that we started this work a year ago or so. I think it's just a general question, not specific to Wuletawu, but the question I have is the big data analysis versus the products that we generate out of that. Okay, I think this big data analysis is a very good tool and a system that we can use data, historical data mostly. In fact, some also future data, but mostly the analysis of the data that we have historically is informative in a sense that it can reveal relationships, it can show us some insights which were not, oversimplified or not understood well in the past, and also generating, high-level insights both to users and even researchers. But my question is, can we use this kind of data to provide real-time advisories, which are dependent on real-time data right now? So are we really interested in that, or are we really interested in the type of products that we want to produce to influence, the ones I mentioned, higher level decisions, insights and information, rather than providing, kind of real-time advisors that are influenced by the data and situations on real time. So maybe it would be good to discuss these kind of things and have a common understanding of what we mean and what we can provide. Thank you very much.
So I can give first feedback and then others can complement on that. So in terms of analysis, if we want to apply the output of this big data approach for advisory or for real-time recommendation, for example, if you use some historical rainfall or let's say climate or soil information, another product up to now, and you use another forecast data from now on, then that will be a problem. But I think what I am thinking is that if you use consistent product in terms of inputs, for example, if you use chips or if you use another climate information that is consistent from historical, where what you use to train, to validate the model, and then to predict or at least to recommend the current advisor in terms of fertilizer and climate information, that could be sort of okay, because the input, the calibration, the training, and then also the forecast is the same product. So that means there is no much change in terms of the behavior of the model because you use the same data. I mean, not the same data, but the property of the data is the same across all the years. But if we train a model with another historical data and then we change another and we use the same model to predict the future, and then that will be a problem. So I'm thinking around that to choose a data that have historical and also nowcast or forecast data. Just the first comment, and then we can discuss more.
Other contribution to
that? I think what can they raised, I think last year, I don't know, in a small group discussion, we also raised this, and we discussed a bit on the difference between a near real-time advisory and a historical kind of analysis. So in our case, even for the use case we're developing, we have discussed this. That's why one of the reasons I was saying this predictive-based plus process-based linkage. What we will do is the historical data set will enable us to initialize the understanding, and we have recent data sets that are brought as well, which are combined, and then the climatic conditions are more or less near real time. And what we'll do is agronomic practices and others will be included as we zoom in. So first we'll have a general information about how the response looks like in a certain environment. Then we have to calibrate and validate for specific and recent near real-time conditions using agronomic surveys, and also the kind of, maybe a process-based model to fine-tune the predictive-based results. So when we are going to develop the advisory one, we have to fine-tune and do a detailed assessment at a detailed resolution. And we're discussing how we do that using, there in Latin America, I think CIMIT and CIAT collaborated on developing a certain tool, which is a kind of agronomic survey based to calibrate and validate higher level, predictive based modeling approach. So that's a good point. And I think last year at some point, we discussed even with Taklu, whether this, have a lot of long time series fertilizer response data, and how do we use those for close to near real-time advisories should be based on real observation to fine-tune and calibrate the data set. Even the kind of linking with process-based models, even though we have to do some work, whether the two will align in some cases because of difference in scales. And also, the data sets that we are going to use for the predictive modeling come from the points themselves, from different localities, even though the density of points may vary across space and the performance may vary. So there is a need to do, the calibration and validation using local data sets to have a dynamic advisory system.
So one until other question come, one thing I believe is that the big data approach, the machine learning approach, is really adaptive for disregarding some of not important information in comparison to some physical process model. In physical process model, you should have a lot of detailed models that are consistent, throughout the year, throughout a different time, and you don't have option also to add more data, which is not already in the structure of the model, and that give you less freedom to be flexible to capture the natural process, the new things, the real time, the forecast. So one of the powerful thing in machine learning is for forecasting, for real time application. And I totally agree there are some discrepancy in terms of historical data in the forecast or the nowcast data. But if we are really consistent in terms of using sort of similar input, then machine learning outperforms the physical models most of the time, because they are really adaptive. They can capture many data which are not directly related to the yield or the process interested, but can help us to capture the reality in real time. That's just a general feedback from my side.
Thank you. Okay, any other comments from the floor? Anyone want to feed in before we close the session? Yeah. Okay. Well, thank you very much, Wuletawu.
There was one comment from Ermes. Maybe if you can elaborate more, but he was saying informing the best available geospatial data, global geospatial data for stakeholders would be good. I have observed several researchers using all data sets. So yeah, I think one of the mission as a geospatial community of practice here should be to, in addition to produce a good output for some of the research questions, also should be like promoting good global geospatial layers to provide for researchers in the country, both in university and also in the cultural research institutes. So I think that is also important. Sometimes the capacity component. I remember with Taku, we have been discussing on the way forward on capacity building for, was a researcher in terms of geospatial, what kind of data is available for the agricultural researcher in the country and what kind of tools they can use. So maybe we can think about capacity building around that.
Sure. Jamal, you had your hand raised.
Okay, thank you, Wuletawu and other colleagues for nice presentation. I'm just give you some comment regarding the big data approach on the application of the predictive model, because as you know, if we think to use the machine learning or artificial intelligence, whatever the big data approach that we are thinking, the original data from the nowcast or the forecast data that we have by its own, so it have an uncertainty of the model forecast due to model error or process bed, whatever you call. So one of the global challenge actually it is to how can we incorporate those uncertainty in, because we call it initialization uncertainty of the model. So we need have to clearly think about how we can handle the uncertainty of the predictive model, big data approach or machine learning, whatever we call it. Yeah. Thank you.
Thanks, Jamal.
Yeah, thanks. I think I totally agree with you. Also, even the soil, not only the climate, the data, the soil data we are pulling from different components, from different people, institutions, they have a lot of uncertainty, and then, we have to struggle how to come up to represent this uncertainty in the model output. Yeah, that's important component.
Great. So there's a bit of conversation about various formats requiring harmonization and standardization. Maybe some of these topics and priorities need to be raised in that session, Dr. Losega, that you'll be leading in the afternoon. Okay. So, okay, sorry, reading responses at the same time as talking to you all. Okay, colleagues, I think it's 12 o'clock your time, lunchtime. Thank you again, Wuletawu, for your session. Very interesting, informative, and I think it's there's need for further discussion, definitely, on the elements that Kindi brought up on real-time versus historical data and so forth. Colleagues, let's return in an hour's time for the afternoon session. We will have Kabi and the ODI presenting the work that they've been doing on developing training material and engagement material around the SADS policy and other topics. So please come back at 1 o'clock your time, and then we resume.